Hey Defenders, welcome back. In the last video, we discussed how we can use Canary tokens to alert us when one of our websites is copied and spun up on a domain that is not a domain that we want that website to be spun up on, right? And we introduced Canary tokens to solve as a defense measure against that. And we just use Canary tokens hosted ability to create tokens, right? But they also give us an ability to stand up our own Canary token server where we can host this ourselves, right? And that is exactly what we're going to do in this video. So stick around and we'll jump into it. But first, time for my shameless plug. If you want to learn more about our company, head on over to opensecure.co. If you would like to hire us for a project, select the Contact Us link in the description of this video. To see firsthand the power of open source, take advantage of our interactive demo. Select the demo link in the description of this video to start exploring. Now let's get back to the video. All right, so Thinkist are the guys behind Canary tokens, and they have a GitHub where we will follow some instructions to actually stand up a Canary token server on our own. And we're going to use Docker to do so. If you're not familiar with Docker, there are a ton of YouTube videos already put together detailing kind of what Docker is, how to get it running, and the technology behind Docker and the framework behind Docker and an overview of what it is and what it does, right? I'm not going to cover that in this video. It's kind of out of scope for what we're focusing on as of now, but we're going to spin up a Dockerized version of Canary tokens, right? So I'm doing this just from a blank Ubuntu box, so I'm actually not using CentOS like we've been using in the past. I'm actually going to use an Ubuntu box to do so. And let me throw this off to the side so we can start to follow along. So we'll first need to install Docker. I don't have it currently installed, so they link to the Docker documentation. So I will select Docker for Linux. I'm on an Ubuntu box. I'll go down to that. Blah blah blah, uninstall. No, we're looking to install a stable version. All right, so let's go ahead and copy their repo. So I'll do an update to get anything I may be lacking. Looks like we're okay there. Say yes. Okay, looks good. I'll download their key. Unable to oh, that's fine. It should exist already, so I'm not worried about that. We'll copy this. Looks like this is just setting the stable. Yep. Okay, so we're just saying we want the stable version of Docker. So we'll copy that in. Okay, that looks good. And we'll do an update again, and then we will install Docker. And hit yes to that. All right, and Docker is installed, and let's just give it a test run. We can do so by running this hello world, and sure enough, it downloaded the image from Docker, and we get a hello from Docker. So it looks like we have Docker set up, so that's pretty easy to do in just a few commands. We will also need to install Docker Compose as well, but let me go ahead and clone this. So I'm just cloning their repo now, and I'll go ahead and cd into this directory. We're going to use Python pip. Let me see if I have Python actually. Okay, so Python 3 I have, okay. If I do pip, what do I get? Pip command not, oh, let me try pip 3. Pip 3 not found. Okay, so let me go ahead and install that. And that's what they're saying here. And then they're suggesting the Python development as well. So probably have to specify Python 3-dev. But let's see here in a sec once I get pip 3 installed. All right, that's installed. Now let's try that. Now let's install this Python-dev. Okay, so we already have that. Okay, so depending on what version of Python you're running, Python 2 is decommissioned, so I would highly advise migrating to Python 3 if you haven't already. But depending on what version of Python you're running, if I was Python 2, I would just replace my 3 here with a 2, right, to install these two dependencies. Now let's install Docker Compose. Actually, let's make sure this lib yaml-dev, I guess this is some YAML library, is installed as well. All right, and now let's run a pip install of Docker Compose, and I'll need to say pip 3. If I was running Python 2, I would just do pip 2. But I'm running pip 3, and now we're installing Docker Compose. And that looks good. Yep, okay. And now, now we should be ready to get, so now we have the Docker software installed onto our server. And what we're going to do is CanaryTokens is going to run as some containers within Docker. So within Docker, if you're not familiar with it, you can spin up containers which can load and run whatever you want. And that's kind of the beauty and why Docker is so popular. You can spin up many containers within one server that could actually be running like a handful of operating systems, and it's pretty cool technology, so I highly advise you guys checking it out if you're not familiar with it. But let's go ahead and continue on with this. So we need to set our configuration files, and they have this switchboard and front end files. So looks like we'll need to copy and rename them. Okay, so let's copy that to just switchboard.env, and then we do the same for the front end. Call it frontend.env, and let's open up the frontend.env, and we'll go ahead and set this here. So here's where we set our domains, right? In a production environment, I would actually do opensecure.co, right? And you would do your actual domain name, right? Like say opensecure.co. So I would set a domain, and then I could do an NX domain of, let's say if I had a subdomain of like token.opensecure.co, right? So as you guys saw the JavaScript that we were loading into that we were setting into our HTML page, right? And so that's where this value comes into play. So if I open this with Notepad again, you can see we ended up replacing it with just an IP address. But our NX domain, so what CanaryToken, when the JavaScript would run, what it would call out to would be token.opensecure.co, right? This wouldn't be obvious to an attacker that, hey, this is actually a CanaryToken tripwire that is being called within this JavaScript here, right? And you could name this domain whatever you wanted, right? You could really obfuscate and be like race car, right? And it wouldn't be clear to an attacker at all what's going on. So that's what we're specifying here. And then you would, of course, update your DNS records to actually point to token. You would update DNS records and specify the IP address of the server running CanaryTokens to this name of token.opensecure.co. For this example, though, I'm not going to do that, so I'm actually just going to set it to the IP address. If I run an if config, let me grab that. So if we run an if config, we see the IP address that is externally facing. So I would just change my front end to not a domain name, but I'm just going to do the straight IP address here. All right, and I will save that off. And now let's do the switchboard side of it. So the one well, not really downside, but one other step you would have to take into consideration is the SMTP service, right? So in the last video, we use just whatever SMTP server CanaryTokens is using to email us, where when hosting it ourselves, we'll need to they give us the ability to set up, to use some third-party SMTP services like Mailgun and SendGrid and Mandrill, so we could just upload an API key within here, and it would call out to the third-party service here and would actually send the message. We can also point to our own SMTP server. And I think they detail that down here. We could also point it to our own SMTP server. I'm not going to do that in this tutorial though, but they provide the documentation for it on their GitHub as well, so you can follow that along there. So I'll set my public IP to that address. My email I'll just say, this won't actually pertain to me because I won't actually get emails, but I'll just say info@opensecure.co. To display, I'll just say, please subscribe. In the subject, I'll say, and tell your friends. Okay. All right, and that we can save that off, and then that should be it. We should be ready to run. So now we have that set. And let's go ahead and download and initiate the images with just Docker Compose up, right? So that's what we just installed here. We installed Docker Compose with this slew of commands here. And now Docker is now creating containers that'll run our CanaryTokens service for us. So once this completes, we should be able to interact with our CanaryToken server. I'm just running this in the foreground, but if you want to run it in the background to where whenever you exit out of your session, right, it'll still be running. You would just do a -D at the end, so that would run it in the background. And that's of course how you would want to run it. In a non-demo environment. And it looks like we got an error. Okay, what's going on here? Port 53 address already in use. Oh, sure enough it is. Okay, what service is bound to that? Systemd resolve. All right, let me see if I can stop that. Systemd-resolve. If I do a netstat again, okay, port 53 is unbound, so I should be able to now run the Docker Compose. Okay, let me run a Docker container ls, make sure those weren't created. Oh, they were? Okay, so let me stop those other ones. I think it's Docker stop, and then I provide the container ID. Yep. Okay. So I'm just killing the two containers that it did successfully spin up. It wasn't able to get this switchboard one because port 53 was already in use with this other service, systemd resolve. So I guess that tries to resolve hostname. So I don't need that service to be running, so I stopped it, which will clear up port 53. So I'm now killing these two containers. Let me do a Docker Compose up again. And now we should be able to run this. And okay, yeah, it looks like we are good. That all started up for us. So now let me get the external IP address of this guy. So and now you actually see all of our Docker containers, right? Are spinning up virtual interfaces. And if we run a netstat again, we'll see Docker has some ports open for us, right? So port 80 will be to interact with our web UI. So if I grab our external address, here we go. And let's go ahead and navigate to this guy. We're port 80. Now you can see, hey, we have our own CanaryTokens web UI that we can now create our own tokens with, right? So and we'll call back to our own CanaryToken server rather than the third-party server of Canary tokens. So let's do the same thing. So we'll clone a website. Provide an email. I'll say info@opensecure.co. I'll say please subscribe. And I'll do a domain of just opensecure.co again. And let's create my token. All right, so we have that created. So we see similar, right, in the last video where we're specifying the domain has to equal opensecure.co. If not, then it's going to fire, right? And that's what the if not is what's represented with the exclamation and the equals sign. And then we get the rest of our JavaScript. And now instead of pointing to CanaryTokens.com, right, we are actually pointing to our IP address. And that's what is pulled within the front end environment, right? So if I go back into the Canary tokens folder and run and open the frontend.env, it's taking our values that we set here and is setting that for us. So, you know, in a actual production environment, again, I would want to change that to like racecar.opensecure.co or something like that, right? But this is just the callback address. So I could leave this as an IP address if I wanted to as well. So we'll go ahead and copy that. And let me go ahead and replace our previous example with this guy. And of course we obfuscated it. So before obfuscating it, let's try to just run it normally. All right, so I have that saved off, and let's go ahead and open this. All right, and we should, in a sec, get this alert. So if I go to manage, let's select the history, and bam, you can see that we actually have reported an incident, right? So we just triggered our alert, which is great, right? It's exactly what we wanted. We don't have the map because you have to have a Google Maps API, which you would just upload here. It's not hard to get one. You just have to sign up for it, and I didn't do that for this demo. But if you want a geo map which uses Google Maps to build, you would just stick your API key in here. But I'm not worrying about that for this example. And then we can go ahead and obfuscate this, right? So if I go to our JavaScript obfuscator, open this guy up. Let's copy our text again. So copy our JavaScript again. Place that here. Go ahead and run that obfuscation. And you can see where we have, you know, opensecure.co is what the domain has to be, right? So we see that within this text here. And then we should see our IP address. Yeah, and we have that here. So here is where we're calling back to, right? So again, this isn't obvious that this is again, I would replace this with a domain name that my company owns, so it wouldn't be obvious at all of what this JavaScript is doing. So I can go ahead, or I should already have this opened up. Yep, and replace that. Save that and reopen it, and we should now trigger another alert. So I'll just refresh this page, and here we see our second alert, right? And we see the IP address where I'm coming from. It has, I guess they do some logic internally, see if it's associated with a Tor node. And then we also see the location. So if this was loaded at hacker1.com, we would see that. And with this, we can also create other tokens. I'm not going to do that in this video, but stay tuned for some future ones, and we'll create a Word document. You can see we can executable or binary file as well, right? So we can trigger this to be like, I don't know, reboot server.exe or something, stick it on some Windows servers. And if this is ever attempted to be ran, we'll also call back to us as well. Right, we can put it on some repos, alert when an AWS key is used that isn't used by us, right? So there's a ton of different tokens here that you can really explore. But now that we have the infrastructure set up for Canary tokens, we can go ahead and take advantage of some of the other kind of tripwires. Again, this isn't a total catch-all, right? You can't rely on this as your total cyber defense, but this is just another tripwire set up to hopefully catch and stop attackers before they're even able to successfully attack you, right? And is a cool and fun little tool to use. Of course, I'm not getting emails because I didn't set up the SMTP service. So you would either need to point to your own SMTP server or use some of these third-party guys and just create API keys. And so essentially, Canary tokens would use these SMTP services to actually generate and send out your email alert. Of course, you don't need that. You could just go into your history of the token to see what, if anything, has triggered. But I would recommend setting up the SMTP services so you can get an email alert on it, right? And so so you see it when it actually happens and not a few days later, giving the attacker time to actually run their campaign or whatever they are trying to do. But we have our own infrastructure set up, which is great, and I always like hosting things myself, and not relying on third parties to do it for me. And thankfully the Canary token guys give us the ability to do so. So I hope you guys found this video helpful, and I look forward to seeing you in the next one.